completing the square to write the quadratic function f of x is equal to x squared plus 3x plus 1 in standard form, and then I identify the vertex. Standard form of a quadratic function is f of x is equal to a times the quantity x minus h squared plus k. So we're going to start here with our function. F of x is equal to x squared plus 3x plus 1. In this function, the leading coefficient is 1. That is, the coefficient of the x squared is 1. And so what I want to do is I want to complete the square for the linear term 3, or 3x. So we have x squared plus 3x, and I'm going to deliberately leave some space here, plus 1. So in order to complete the square, I want to take half of the middle term, or half of the middle number. So that is half of 3, and if you like, you can write it as 3 over 1, and then square that result. So then I want to square this result. So 2 does not go into 3 evenly, and I want to keep this as a fraction. So I'm going to write this as 1 times 3 is 3 over 2 times 1 is 2. And then I'll square this value. So if I square 3 halves, this is equivalent to 3 halves times 3 halves, or 9/4. So to complete the square here, I'm going to add 9/4 as well as subtract 9/4. If I add and subtract 9/4, then the change is 0. So these three terms here are the perfect square trinomial, and I want to write that in factored form. So that is x times x is x squared. So the first term of the binomial is x. And 3 halves times 3 halves is 9/4. So I have 3 halves as the second term of the binomial. Now, the middle term here is positive, which means the sign in the binomial will also be positive. So if I factor x squared plus 3x plus 9/4, that is going to factor into x plus 3 halves squared. And then the numbers here on the right, I want to add. In order to add these two numbers or combine these two numbers, I want to get a common denominator. And the common denominator here is 4. So I can rewrite 1 as 4 over 4. 4 over 4 is equivalent to 1, minus the 9/4. So bringing this down an additional step, we have x plus 3 halves squared. Here we have a common denominator. So I'll write down the common denominator of 4, and I'm combining the numbers 4 and negative 9. So that's going to give us a negative 5/4. So the function f of x is equal to x squared plus 3x plus 1 in vertex form is f of x is equal to x plus 3 halves squared minus 5/4. And then if I write the vertex of this function is the opposite value here. So that is negative 3 halves, and exactly what we have here outside the function, minus 5/4. So the vertex is negative 3 halves, negative 5/4. And that's an example of rewriting a quadratic function using completing the square in standard form.